All right, this is a 2004 question 5. A rural county hospital offers several health services. The hospital administrators conducted a poll to determine whether the residents' satisfaction with the available services depends on their gender. A random sample of 1,000 adults, county residents was selected. The gender of each respondent was recorded, and each was asked whether he or she was satisfied with the services. The resulting data are shown in the table. Use a significance level of 0.05 to conduct an appropriate test to determine if, for adult residents of the county, there is an association between gender and whether or not they were satisfied with services. So here's some keywords: association, independence, dependent. Typically mean we're running a chi-square test of independence, assuming that we have something that we can put into a matrix. Well, there was one year they slipped us up. They said it was association, but they wanted a chi-square test of homogeneity. So I need to go back and check. And I see I have one sample. One sample, 2+ variables, tells me I'm running a chi-square test of independence. So I'm going to take a moment and input this data into the calculator. But this is a chi-square test of independence because we have a matrix and we have a single sample. All right, so we determined that it was a chi-squared test of independence. And here's the values that I'm going to need to enter the calculator. And I just wanted to talk about that real quickly. We don't enter the totals. So it's going to be a 2x2 matrix. And we have 2 rows and 2 columns. And our degrees of freedoms are rows -1 times columns -1. So 2 - 1 times 2 - 1. So just plain old 1 would be our degrees of freedom in this case. Something else I wanted to talk to you about is if I wanted to actually calculate it on independence, I could go this times this divided by this. So to calculate it, if it's for independence, to calculate the expected or the independent values, it's row total times column total. Oops. Row total times column total over total total. And we'll look at that in just a moment. So I've entered this stuff into the matrix. And here's the way I did that. I pressed the second button and the button below the math button, arrowed over, and I entered a 2x2 matrix, so 2, enter, 2, enter, and I just entered that data, 384, 80, 416, and 120. All right, so let's go ahead and start writing our null and alternative. Satisfaction with service and gender are independent, which means they are not associated. Again, I always like to write with a positive because that's what we've been doing all year long. And then satisfaction with services are not, so they are associated. All right, please remember, if you're independent, you're not in a relationship. If you're not independent, that means you are associated with something and you are in a relationship. All right? Random sample given. They said it was a random sample of 1,000, I believe. Yes, random sample of 1,000. So we need to assume that there are at least 10,000 county residents, and our sample size is less than 10% of the population. And then we need to do the expected values, see table. Well, that's why we entered that stuff in the matrix. So we entered the matrix, and we're just going to go ahead and escape. And then we're going to go stat, run the test, and this is a chi-squared test. It's not the goodness of fit. And we'll just go all the way through this. And we end up getting a chi-squared value of 4.11 and a p-value of 0.0424. So we're going to need that. And we have a p-value of 0.0424. If we had an alpha of 0.05, this is less. So our decision would be to reject, but we're jumping ahead of ourselves. Oh, and this shows our degrees of freedom. So we're jumping ahead of ourselves. We've named our test, but until I have these expected values, I need to make sure that I can even run this test correctly. So I have to go back into the matrix. But we're going to go to a different matrix. So second, followed by the button below the math button. Go to edit. And our new matrix will be in matrix B. And there's my values. So I write them down, and I notice that all of them are greater. All of these values happen to be greater than 5. So we're good to go there. Now, I was saying that I could actually calculate this by hand. I could have gone 464 times 800 divided by 1,000. So let's try that out. 464, or excuse me, yeah, 464 times 800 divided by 1,000. And sure enough, I get 371.2. If I try it here, 464 times 200, divide that by 1,000, I get to 92.8. So basically, you can do it by doing row total times column total divided by total total. And it's important to know that because that's likely to show up on a multiple choice. All right, so I'm going to go observed minus expected squared over expected, and I'm going to take the first one, which is this one, and the second one will be the last one. The first one and the last one. So observed minus expected squared over expected, and observed minus expected squared over expected. So we have a small p-value, so there's plenty of evidence to say that they are not independent. In other words, we could say that they are associated. All right? The last part of this. Is 800 over 1,000 a reasonable estimate for the proportion of all adult residents who are satisfied with the service that's offered by the hospital? Explain why or not. Why or why not? Well, we have 800 out of 1,000 that are satisfied. Well, yeah, it is reasonable. Why? We took a random sample so we can generalize it to the population of interest, right? Because it's a random sample from the population of interest, we can generalize it to the population of interest. All right. Well, that'll take care of that one.